Have you ever wondered why your shiny new kettle gets that chalky white buildup inside? Or why your laundry sometimes feels just a little bit scratchy, even when it's clean? Well, the culprit is something called hard water. And today we're going to break down the science of how we tame it.
You know, it all starts with this really simple, almost frustrating everyday experience. You go to wash your hands, you add the soak, but instead of this rich, satisfying lather, you just get this weird, kind of sticky film. So what's going on? Well, the answer isn't in the soap, it's in your water.
So, to solve our little soap mystery, we first have to understand what we're actually dealing with. Let's dive into what hard water really is and why it's causing all these annoying problems in the first place.
Okay, so here's the deal. Hard water is basically just normal water that, on its journey through the ground, has picked up some invisible little hitchhikers. These hitchhikers are dissolved mineral ions, mostly calcium and magnesium, and these two guys, well, they're the ones getting in the way of your soap and causing a whole bunch of other headaches.
And believe me, the trouble doesn't stop with soap. Those minerals build up over time and can clog your pipes, kind of like cholesterol in an artery. They're what create that stubborn, filmy soap scum on your shower door. They mess with your detergents, which is why your towels can feel stiff and scratchy. Those spots on your drinking glasses after they come out of the dishwasher? Yep, that's them too. And they even make appliances like your water heater work way harder, which just wastes energy and money. So how do we actually fight back against these mineral troublemakers? Well, for more than 100 years, the first major line of defense, especially for entire cities, has been a really clever chemical trick called the soda-lime process.
The idea here is actually pretty simple, but it's brilliant. If the problem is that these minerals are dissolved in the water, what if you could just make them undissolve? What if you could force them to turn back into tiny solid particles that you could literally just filter out? Well, that's exactly what this process does.
Here's the play-by-play. First, they add two key chemicals to the water, lime and soda ash. These chemicals immediately go to work hunting down those calcium and magnesium ions and starting a chemical reaction. This reaction basically forces the minerals to clump together and form solid particles. It's a process called precipitation. Then, the water just gets passed through a filter, the solids get left behind, and voila, the water is soft. Now, because this involves massive tanks and really precise chemical measurements, you're not going to find one of these under your kitchen sink. This is the heavy-duty workhorse for entire cities, treating millions upon millions of gallons before that water ever gets to your house. All right, so chemical treatment works great on a huge scale. But what about a more natural approach? The next solution, the zeolite process, uses a special kind of mineral to solve the problem. And it introduced a really revolutionary idea that's still at the heart of water softening today.
This quote really nails it. The key concept here is ion exchange. Instead of forcing the minerals out with chemicals, this method is way more clever. It trades them for something less harmful. It's a totally different strategy. So think of it like this. You have a filter bed made of this natural zeolite mineral, and it's already holding on to a bunch of harmless sodium ions. When hard water flows through, the zeolite actually prefers the calcium and magnesium. It has a stronger attraction to them. So, it literally grabs the hard minerals out of the water, and to make room, it releases a sodium ion in exchange. The bad stuff gets trapped, and softer water flows out. Of course, eventually, the zeolite runs out of sodium, so you have to recharge it by flushing it with salt water, which loads it back up for the next round. Now, while you don't see this exact method as much anymore, the zeolite process was a huge stepping stone. It was the proof of concept. It showed the world that this whole ion exchange idea was a super powerful and elegant way to soften water, and it really paved the way for the tech that most of us use in our homes today.
Which brings us right to our third and final solution, the modern ion exchange process. This method basically takes that brilliant trading concept from zeolite and perfects it with modern engineering.
The core idea is exactly the same. It's a mineral swap. But instead of a natural mineral, this process uses these tiny, synthetic, man-made resin beads that are hyper-efficient at doing this one job. You can think of them like tiny bouncers at a club, specifically designed to grab the troublemakers, calcium and magnesium, and swap them for a preferred guest, sodium. So, a modern home water softener works just like the zeolite process, but on steroids. Hard water flows into a tank full of these super efficient resin beads. The beads have this powerful chemical attraction to calcium and magnesium, much stronger than their hold on the sodium ions. So they just can't help themselves. They grab the hardness minerals and release the sodium. The bad ions stick to the beads and perfectly soft water flows out to your faucets. And just like before, when the beads are full, a saltwater flush, called regeneration, cleans them off and gets them ready to go again.
If you have a water softener in your basement, or you see one at a restaurant or an office building, this is almost certainly the technology it's using. It's incredibly effective, it's efficient, and it is the gold standard for tackling hard water in our homes and businesses today.
All right, so we've looked at a big chemical process, a natural mineral process, and a modern synthetic process. Let's just pull back for a second and put them all side by side for a really clear final comparison.
This table really tells the whole story, doesn't it? You can see the evolution right here. We started with the soda-lime method, a brute force chemical approach perfect for cities. Then we moved to zeolite, a more elegant natural ion exchange. And that led us to the modern ion exchange, a highly efficient synthetic version that's become the standard for our homes. Each one has its perfect application, but the goal is always the same: get those hardness ions out.
So, from these massive citywide treatment plants all the way down to that softener humming away in your basement, it all comes down to one simple objective: getting rid of those pesky calcium and magnesium ions to give us better, cleaner, and more efficient soft water. And that brings up a really interesting final thought. We have gotten incredibly good at removing these common minerals, but as our technology gets better, what are the next invisible challenges? What about things like microplastics or tiny traces of pharmaceuticals in our water? What's it going to take to solve those problems? That's the next big question for the future of clean water. Thanks for joining me.